Hello, welcome to this video. Today I am making a Sketchpad file that illustrates transformations using matrices. Okay, so what I did here was I turned on my coordinate system by going to Graph, Show Grid. I already did that. Okay, next I plotted some points. I plotted the point 0, 1 and 1, 3, and then I made the line y equals 2x plus 1 through that line. And I also plotted the point B at 3, 2. Now our goal is to reflect point B over the line y equals 2x plus 1. First of all, I'll do that using Sketchpad the easy way. You just double click on the line and that marks it. Click on point B and then go to Transform, Reflect, and that's the easy way using technology. Point B reflects over the line y equals 2x plus 1 to be the point negative 1, 4. Now we're going to look at that, how to do it using matrices. Now, using transformations, what we're going to have to do, since it's y equals 2x plus 1, this plus 1 here, we're going to have to translate point B by a rectangular fixed distance of down 1 centimeter or 1 unit. So we're going to translate it down 1 unit because it's 2x plus 1. Now we can rotate this point about the origin. So let's mark the origin and let's rotate it negative 63.4 degrees. And I got that number from using the inverse tangent for the line y equals 2x. That's the angle that it makes with the x-axis. So when we rotate it negative 64 degrees, this point is rotated down here. Now we can reflect that over the x-axis. It goes up there. Alright, now we have to go backwards and we have to rotate it back 63.4 degrees to the positive now. Okay, now you notice it's over here. Now we just have to transform it or translate it 1 unit back up. Translate by a positive 1 unit, and that puts it right back on B prime. So through this compositions of transformations, by going down 1, rotating it 63.4 degrees, reflecting over the x, rotating it back, and then transforming it back, B is reflected over the line y equals 2x plus 1. Now I'm going to show you how to do that using the matrices. Okay, now looking at all this mess of matrices, I called Z the matrice to move it down 1 unit. So Z, this negative 1 here, it translates it down 1 unit, which is this first translation. Later on at the end, to translate it back 1 unit, up 1 unit, that's Z inverse. A is using the rotation of negative 63.44 degrees. You plug negative 63.44 into sine, cosine, negative sine, sine, and cosine. That gives us this matrix, which rotates it negative 63.44 degrees. Then A inverse rotates it back 63.44 positive degrees. And lastly, the reflection T over the x-axis is given by 1, 0, 0, 0, negative 1, 0, and 0, 0, 1. So when we do this matrix multiplication, you always go from right to left. So you start at Z, that'll move it down 1. A will translate it rotate it negative 63.44 degrees. T flips it over the x-axis. A inverse rotates it back 63.44 degrees. And Z inverse translates it back 1 unit up. So when you do the math on that, the matrix multiplication, I got that Z inverse A inverse T A Z equals this matrix of negative 1.68, 2.250, negative 0.09, 2.040, and 0.001. So I hope you get the idea how this composition of matrices, transformations, can be used to reflect an object over a line. In this case, I reflected the point 3, 2 over the line y equals 2x plus 1, and it landed on negative 1, 4. There is the easy way to do it using the technology, or as we showed, everything can be represented as a matrix, and you can do a composition of matrices in transformations to show the same thing. So any point can be multiplied by this matrix to show where it would be reflected over the line y equals 2x plus 1 to. I hope this made sense to you as we discussed, and hope you enjoyed it. Have a good day.